A student has a debit card with a prepaid amount of $270 to use for his school lunches. The cafeteria charges $4.50 per lunch. Write an expression for the balance on the card after buying X lunches. Does your expression make sense for all positive integer values of X? And how many lunches can the student buy? Okay, right here, write an expression for the balance on the card. Now the balance, well, he started off with how much money? 270, and then he's got to subtract $4.50 times each lunch. Okay, per lunch means we're going to have, with X lunches, we're going to take $4.50 times the number of lunches, and that's how much he's going to use. All right? His balance, you start off with $270, subtract $4.50 times the number of lunches he's used. Now, that's your expression. Does your expression make sense for all positive integer values of X? Well, you have $270 to use, right? Okay. When you use up that card, you're going to have a balance of 0, aren't you? The problem with this is if you buy too many lunches, you could have a negative balance. Okay? And you cannot do that with a debit card. Okay? Once you get to 0, you're done. So you can't have a negative balance. So you can't buy too many lunches. Okay? So it doesn't make sense for all integer values, positive integer values of X. Okay? Once you get up to a certain level, then you've used up all your money and you can't go any higher than that. So it doesn't go on forever. Okay? So that's the problem with saying it makes sense for all positive integer values of X. You can only go up to a certain level. Now, what is that level? It's the answer to the next question. How many lunches can the student buy with a card before he gets down to 0? Okay? So here's my expression here for the balance. We're going to take this and solve this for 0. Solve this for X when this equals 0, when he's used up all of them. Find out how many lunches did he buy with this $270. Now, notice the variable is X. The coefficient is a negative 4.50. Okay? I don't like having a negative coefficient for X. Okay? I know that if I have a negative coefficient for X, I'm probably going to make mistakes. So my first thing that I do that most people don't do is I add 4.50x to both sides of the equation. Watch what happens. Put a plus 4.50 here and here. Bring down the 270. Bring down your 0. This is negative 4.50 plus 4.50 is 0. You don't have to write it, or you can if you want to. Then you have your equals, and you have a positive 4.50x. I know I'm going to make less mistakes if the coefficient of the x, the number in front of x, is positive. Okay? Now, we have 270 is 4.50x. My variable is, you're solving for the variable. The coefficient of the variable x is what? Okay, when you have two terms, here's a term here, here's another two term, separated with an equal sign, that's when you divide by the coefficient of the variable. The coefficient of the variable is 4.50. X is the variable, 4.50 is what we're dividing by because that's the coefficient of the variable. Take 270, divide it by that coefficient, take your 415, divide it by the coefficient. Now these cancel, that leaves you x, here's your equals, and when you do the math here, you're going to come up with 60 lunches. So how many lunches can the student buy? X lunches, or 60 lunches, is how many he can buy. Above that, if he tries buying 61, he's going to run out of money. So he can't get 61. That's why it doesn't make sense for all positive integer values of x. You can't go over 60. Okay? So here's your expression for the balance. It doesn't make sense when x is greater than 60. 61, 62, and 63 can't be it. Can't do it. It's a debit card. And x is 60. The number of lunches is 60.